Okay, thank you for attending the user meeting here in Milan this year. My name is Patrick Schaub and I'm going to talk about CAPsManager version 2 to you. And I'd like to focus on new settings that we see in the last CAPsManager version or in the latest release candidate. I want to have a look at Spectrum usage and how to use it efficiently. And finally want to go into possible security features or encryption features that we can use with CAPsManager. Before we start, I want to drop a few words about our company, FMS Internet Service. We're a value-added distributor. That is, we're a pure distributor on one hand, but we do a lot of training, consulting services, and support for our customers too. And MikroTik used to be a very important product for us for many years. The company was founded 20 years ago, and by today we're 11 people, and we're located in the south of Germany, right next to the Swiss and the French border. As I said, we're doing a lot of training, and here are a couple of photos of our on-site training room. Speaking about MikroTik, we are two trainers, myself, and especially Sebastian Inacker. He's our leading trainer, and he will have a presentation here tomorrow about CRS and switching, so maybe you have the chance to listen to that one too. We also have a table here in the distribution or exhibition area. This is actually a photo of last year's table, so maybe you're interested to drop by. We brought quite a few products, and we are having a few live setups this year. On one hand, we're showing Nokia's V+ setup. V+ is a new DSL or upcoming DSL version that we brought for you. We have a demonstration of their enterprise or carrier-grade management system. And we're running a 10G test on 10 meters of Cat5 copper cable. That's maybe worth to see and something Sebastian is going to refer to in his presentation tomorrow. For those of you who plan to build masts or towers this year, we also brought a few pieces of our modular mast system. So if you're interested, we'll be happy to talk to you about that. Now, before we start into the presentation with a few maybe more advanced topics, I want to give you a brief introduction into CAPsManager. So those of you who are not using it so far, at least know what it is to follow the rest of the presentation. And I have 2 slides or 3 how to get it running at first. CAPsManager is MikroTik's Wi-Fi controller, and its approach is a bit different from some competitors' controllers, so it's interesting to understand what it's really doing for you. From my point of view, one of its major features is the provisioning capability. That is, CAPsManager will be able to automatically configure all the access points in your network. And you can compare it to an ACS, maybe using TR069, what some of the ISPs might know for their CPE. It's quite comparable to that. Next to provisioning, we're also having the possibility to authenticate all of our clients at the access points at one central instance. That's the controller. And you also have access control, central access control for these clients there using access control lists. Something that makes CAPsManager pretty special compared to other approaches is that we can, if you want to, also handle the traffic that comes from the connected access points. So if you choose to, you can have all the traffic from your clients pop up at the controller directly. And that's a pretty powerful feature that will enable quite a few interesting configuration possibilities. And well, last but not least, you also have the possibility to monitor all your clients at a central point. That's especially handy when your customers call in and have problems with certain clients, as you can see all of them at one system, your CAPsManager. As I just said, the handling of traffic or the traffic handling capabilities are a bit special, so I want to make sure everybody understands that. We have one possibility that's local forwarding mode. In local forwarding mode, your access point will handle the client traffic as it usually does. So you will have a manual configuration of your access point, and the traffic is just sent out to maybe the Ethernet 1 interface to your local network, and CAPsManager doesn't really care about what you do. And there's manager forwarding mode. That's the default in CAPS Manager setup. So if you don't choose something else, it will be in manager forwarding mode. And that way your access point does not need any additional configuration. So it's maybe not even necessary to set up an IP address for the access point, but it will create an automatic UDP tunnel from the CAP, from the access point to the CAPS Manager and send all client traffic along that tunnel. So that way, client traffic cannot break out into the local network, but will start popping up at the CAPS Manager. Just a short slide on how to get it running if you've never installed it so far. In older versions, it used to be necessary to install the CAPS Manager package first, but that's not true anymore as it's part of the standard package. So as the package is already there, all you have to do is configure the CAPS Manager itself, create a provisioning rule, create a configuration for the access points, and finally configure your access points to really use the manager. The controller's configuration is done in the main menu at the CAPsMAN button, while the access point is configured in the wireless window on the CAP button. To get the CAP, the access point going, just enable the feature. So you enable it to talk to the CAPS Manager, and then you can choose which of its wireless interfaces should be provisioned. That's what you see in the wireless setting over here. Usually you want to provision all of its interfaces. And in the most simple setup, that would be a layer 2 setup where access point and manager are within one layer 2 domain. You will choose a discovery interface. That's the interface the access point will look on for a CAPS Manager. It will simply send out broadcast packets and the manager is going to answer, and then the two of them will negotiate all the rest. So that's all you have to do on the access point. And on the manager, there are a couple more steps necessary. At first, you have to enable the service to make it listen to these broadcast packets at all. Then you want to care for traffic handling in manager forwarding mode. That is, in this example here, you might create a bridge and add the WAN interface of the manager to that bridge. Finally, create a provisioning rule. Provisioning works a little bit like firewalling. You can set different conditions, and if all the conditions of the first rule match, it will take the action that you did set in that rule. In our example here, the only condition is a MAC address of all zeros. That will mean any access point asking the CAPS Manager for provisioning will match that rule. And our action is to create a dynamic enabled interface and use the master configuration named over here. The configuration in turn, the minimum configuration is rather small. We just set an SSID in the top right window, and on the bottom right in the data path configuration, you set a bridge where that virtual interface or that dynamic interface will be automatically added to, so that your clients will push their traffic all the way through the UDP tunnel onto that bridge on the CAPS Manager. So that was it for a short introduction on how to get it running and what it's going to do for you. And now we want to have a look at the latest features that have been introduced in CAPS Manager. The first one, an additional band setting, actually isn't that new at all. It has been introduced in 2016. But as I want to talk about spectrum usage, I think it's important to understand that since a couple of months we can limit our band to GN in 2.4. Doing that means we are not supporting legacy mode anymore, like 11B. And there are two things to know. On one hand, you will not see many 11B clients in your networks anymore. And enabling 11B will reduce the performance of your 2.4 gigahertz base station or network. The reason for that is that 11B is using a different modulation. It's based on DSSS modulation, while all the newer standards will use OFDM. And if an OFDM node has to be backwards compatible with DSSS, you will lose capacity since we have to take care of the DSSS timing and have additional overhead. So our suggestion clearly is to disable legacy mode, and that's something you can do starting 2016. One of the really new features is that one, that's the discovery interface. It's present in the release candidate, but not present in the current stable version. And you just see two screenshots, and you will notice that there's this interface button popping up in the release candidate, which is leading you to the interfaces window. What it does is not a big deal, it's just a convenience feature. You can simply name interfaces on which CAPsManager will be running or is not allowed to run. This can add up to security or will help you not to provision access points that you never meant to provision since they're behind the wrong interface. It used to be possible to do that by manual firewalling, but using discovery interface feature is definitely easier. Another new feature is static virtual, and compared to discovery interfaces, static virtual will really help you to do something you haven't been able to do before. So static virtual is pretty nice. You can configure it on the access point, not at the manager, so each access point in its configuration you have that checkbox, static virtual, and if you check it, the feature is enabled. And before we look what it's really doing, I want to recall what a virtual interface is in my Cortex world. A virtual Wi-Fi interface is typically used if you want to set up additional SSIDs on the same physical interface. So a virtual interface is always connected to a physical one, and it will help you to name a second SSID. It can have different security settings, and of course, since it's an interface, you can handle its traffic differently, like make it be part of another bridge. The problem or the thing to know is that a virtual interface, when it's configured by CAPsManager, it will be renamed, as you see here, from VLAN 2 to VLAN 8. So every time CAPsManager is disconnected from the CAP and reconnected again, the virtual interface is going to be deleted and recreated, and it will change its name when it's recreated. All this is only important when you're in local forwarding mode. Since in manager forwarding mode, you can't do anything with your interface at all, so it's not important if it's changing its name. But when you're in local forwarding mode, you have to and want to do extra configuration for your virtual Wi-Fi interface. Usually you want to handle its traffic, so you might want it to be part of a VLAN or of a bridge. And if that's the case, it's a real problem if the interface is going to be renamed. What you can see on the left-hand side, that's like our starting condition. We have a virtual interface in local forwarding mode called VLAN 2, and it's part of the bridge here called stuff bridge, and everything's fine until CAPsManager is disconnected. And when it's reconnected, as you see in figure 1, the interface is going to change its name. When it changes its name, obviously, the manual bridging configuration is going to break, as the interface that you added to the bridge isn't present anymore. So that's static virtual is a way to prevent this problem. To make things even more complicated, there's another feature which is, oh no, sorry, that's one slide ahead. That's what you see, what happens when we use static virtual. The interface is not deleted. It's simply disabled. So it's disabled when CAPsManager disconnects, and it gets enabled again once CAPsManager connection is back. So it keeps its name, and all its, let's say, individual configuration is still in place. If that would be all that we want to do, there would be another feature present since long that would give you the same thing. That's the bridge feature at the CAP. It used to be possible to name a bridge on the CAP where interfaces in local forwarding mode are put as a port to dynamically once they are created. And that feature would definitely give you the same possibilities as static virtual, but there are a couple of big differences. For example, with the dynamic bridge, you can just use one bridge for all of your dynamic interfaces. You can't do any routing, you can't add IP addresses to the interfaces, nor do firewalling where you want to include the interface's name. So static virtual is quite better than the old bridge feature, but of course the other one is still there. Another pretty new feature is save selected. Safe-selected also appeared in the release candidate in one of the latest ones. And safe-selected is important when you're using automatic frequency selection. That is, if you're setting your frequencies manually, you don't need it. But if you're setting them automatically, safe-selected will save the last frequency for each access point or for each interface that the automatic feature did select. That's important if you're losing connection to your CAPS manager and it's being reconnected. What you see here is 3 static interfaces and the CAPS manager connection is lost. So you see all of them, they're inactive right now. And when the manager connects back again, you see that the automatic frequency selection is not happening for all access points at the same time, but it's happening access point after access point. Which is good, of course, since it would probably not come out with any proper result if it does all of them at the same time. But it means that you have a delay until your network is running again. And you can even watch that if you want to. Have your 3 interfaces. In figure 1, you see that one is running already. It's not inactive anymore, and the state is running access point. While interface 2 is still inactive, but it already entered the selecting channel mode, so it's scanning for a channel right now. The 3rd interface didn't even start, it's still inactive and still showing the last mode it was in. So you see that's happening access point after access point, taking a couple of seconds for each one to complete. Using safe-selected will speed this process up, as they are not going to frequency selection anymore. They just save the last results. And the problem is there if you have a large number of CAPs, since each of them will take a couple of seconds to choose its frequency, so it may take a couple of minutes until your network is back operating after you did lose CAPS manager connection. This frequency selection feature will bring us to the next topic, that is channel planning and regulation. And actually it's kind of a sad topic too, since there are a couple of features we are missing in CAPS Manager today. But the good news is that there are workarounds that you can use, and there are features on its way in MikroTik's next releases. And I think it's important for you to understand where CAPS Manager will need special attention. I'm sure most of you will know the situation in 2.4 gigahertz, but I still want to recap that. Firsthand, there is a big difference between ETSI and FCC regulated countries. As an FCC, we cannot go for channel 12 and 13. So every time you have to set up a public Wi-Fi network, or you will have a bring your own device situation where you can't control what type of devices your network will use, you can simply not use channel 12 and 13, as these customers will not be able to connect to your access point. There's something else, I call it a more general approach, that is only to use channels 1, 6 and 11. Talking about 20 megahertz bandwidth, these will be the only 3 channels that are not overlapping in 2.4. Let's have a short look at that diagram. It just shows you 3 channels, 20 megahertz wide in 2.4 gigahertz, with the first one having its center frequency at 2412 megahertz. When the channel layout was done, the offset of center channels was only 5 megahertz. So if you're going for channel 2, it would be at 2417 megahertz, overlapping by 15 megahertz with the first channel. And it's absolutely pointless to use that, as you will cause self-interference to your network, your SNR will drop, and your data rates and modulation will drop too. So it's common practice, not only for MikroTik, but speaking about any vendor, to stick to the 1, 6, 11 scheme. And if you do so on a MikroTik access point directly, we have very convenient features to do that. By today, we can even create our own channel list, what I do here on the right-hand side. So I add my own channel list, I add the channels 1, 6 and 11, I tell them their center frequency, and I tell them that they shouldn't be wider than 20 megahertz, and also which Wi-Fi standard to use. After you did create this channel list, you can simply use it as a scan list. And even if you stick to auto frequency, your access point will only select from these 3 channels. So you forced him into that traditional 1611 scheme. The problem here is that CAPS Manager doesn't support scan lists by today. And that's actually quite bad, since, as we just learned, we will really have to stick to 1611, and we can't force CAPS Manager to do so. So one of the obvious solutions would be to assign your channels manually, access point by access point, but that, on the other hand, will greatly reduce the advantages the great provisioning features of CAPsMAN are bringing you. Luckily, there is a workaround employing the strength of CAPS Manager, that is its provisioning rules, its modular hierarchical configuration, and it's using regular expressions and setting overrides. Here's a short overview of how we're going to achieve the 1611 setup. As I said, we'll use provisioning, we'll use the configuration, and we will use overrides for the channel configuration blocks. But let's look at that one after the other. So here's the provisioning rules at first. You see four provisioning rules starting from 0 to 3. And I did add some numbers to make it more clear. So at figure 1, you see our first condition will be we want to only support devices that will be capable of 11G at least, because we learned before DSSS in 11B isn't really efficient, so we want G at least. In figure 2, and that's like the base, let's say, trick for our provisioning, we use regular expressions. So I'm setting up regular expressions and simply assume that the system identity of your access point will contain the channel number that you want CAPsMAN to assign to that access point. So we add CH01, CH11, CH06, and CAPsMAN will check the system identity. And in figure 3, you will see that we assign different configurations within the different provisioning rules. There's one more thing interesting here. I added a 4th provisioning rule, which I would like to call a catch-all rule, and that is to prevent CAPS Manager to do its default, or stick with its default, because its default will say, if there is a radio which can't be provisioned, I will create a static interface from it. And typically, if you made up your mind for your provisioning and something can't be provisioned, it's probably wrong. So for any reason, something's not good. And if it's not good, we don't want CAPS Manager to create an interface for it, but we want to have the possibility to find that very radio later pretty easy. And for now, we just create this catch-all provisioning rule, and we use an action of none. That means no interface is created. For the configuration that we use the provisioning rules to assign to different configurations, there are 3 of them for channel 1, 11, and 6. And the advantage in this approach compared to assigning channels manually is that we leave all of the configuration centrally. Everything is still central, so you can change like the bandwidth, for example, at one location, and you don't have to do that for every interface. So we will go ahead and use the building blocks of channels, of rates, of data path, and of security, all referring to the same building block with the settings kept centrally. And there's only one thing, that's the frequency that we will override within the configuration rule. So frequency could also be set down here in the channel building block, but we don't do it. We use an override to have it just at one location. So let's see what happens when our radios are connecting to CAPS Manager and what provisioning looks like. In the bottom screenshot, you can see that one, its system identity contains 01. So actually our provisioning rule or regular expression for channel 1 should match. And if you have a look at the MAC address here, you will find it again over there. And everything worked like a charm. Here, that configuration was used. And we're running at 2412 megahertz, which is channel 1. So all's good over here. also for the other 2 channels. There's something else you can see in the radios tab, that is, there's one radio left which is not being provisioned. That one over here, it doesn't have a P in front of it, and it will not show a CAPS manager interface name. That radio didn't get provisioned, so our 4th provisioning rule, the catch-all rule, was applied to that one with an action of none, so it did not get any configuration. So using catch-all rules, you can go to the radio tab at any time and just look for those interfaces that did not get any provisioning, and you can be sure something didn't work out as you planned it to do or planned it to be, and you can have a look at those radios personally. In that case, for example, it was a 5 gig radio. I didn't take the time to do a 5 gigahertz configuration, and since we required at least G standard, and a 5 gig radio will not support G, it's been left unprovisioned. So going further to 5 gigahertz, there are also regulatory things over there that we should be aware of. In 5 gigahertz, we have 2 regulatory requirements in most countries that you will probably know about. One of them is radar detection and DFS. And by today, CAPS Manager simply does not support either of them, and there is no workaround. But the good news here is this feature is under development right now. If I understood all this correct, it's ready, but it hasn't been tested yet, so it will be available very shortly. So no need to worry about that one. The other regulatory requirement is the difference between indoor and outdoor channels. I think it's true in most ETSI countries, in Germany for sure, that you may not use channels below 5,470 megahertz in an outdoor deployment. As we learned before, there is no scan list support in CAPS Manager by now, so what would you do if you have to, let's say, set up a campground with all outdoor 5 gigahertz equipment and you simply can't avoid indoor channels to be picked by the auto frequency selection? Luckily, there's a very easy solution for that one, as MikroTik did make up a special country code. It's called ETSI 5.5 to 5.7 outdoors. And you just go ahead and set that country code, not your personal one, not let's say Italy or Germany or whatever, but you set that one, and CAPS Manager will be limited to the outdoor frequency range starting at 5,500 megahertz as a central channel. So no need to worry for outdoor installations. There's another difference, again, in most countries, since I don't know all the regulations for the lower subbands and the outdoor subband in 5 gigahertz, that's the maximum EIRP that you will be allowed to use. Typically, in the outdoor band, you will be allowed to use much higher EIRP. And so we get questions regularly from customers who ask us how to force your access point in these outdoor frequencies to be sure is using the highest transmit power. We just saw the solution for that, but I still want to stick with this topic for a second. Speaking about Germany again, for example, we have 30 dBm EIRP starting with 5,470 megahertz, and below we have to go down to 23 dBm. To correct that a bit further, actually we have to subtract 3 dB and not stick with 30 but 27, since MikroTik, as most of the competitors too, is not supporting ATPC, so you simply have to reduce that. Again, here you don't have to care for it. MikroTik does all that for you if you set the country code correctly. I'm just explaining it so you understand the figures that you can see in the user interface. For example, if you set the antenna gain to 0, have an interface in an outdoor channel, that interface will use 27 dBm of EIRP. Interesting here, the antenna gain is the only setting of your interface, of your wireless interface on your cap that has been taken into account. All the other settings in your cap are ignored from CAPS Manager, but antenna gain is still taken into account so make sure you set that before you enable the CAPS manager. So now we see we don't have to care since MikroTik does that themselves, and we would have a possibility to use high IRRP in indoor installations. But let's think if that's really necessary or if that's really good. From my understanding, the opinion of high TX power will solve your problems is one of the biggest problems in Wi-Fi deployments itself. The more the better, that's what we often see, but it's not true absolutely. In this setup, for example, because the Wi-Fi direction is bidirectional, so there's no point in shouting at a device that can't shout back to you. And a small mobile device will definitely have lower maximum TX power than your access point. So usually you can say in high IRRP in such an installation with a low antenna gain at the access point is pointless in the best case or will even cause problems for you. As I just said, the mobile device will not able to send back, it will receive but can't send back. You will cause unnecessary interference for your own network if you start shouting with high power. And it might be even harder for your mobile device to select the best access point to connect to. For example, imagine a close by 5 gig access points in indoor channels and a far away access point in outdoor channels. The mobile device might hear the far away access point better due to its +7 dBm of output power, so it might connect to that one, but it will hardly be able to talk back. So you might see the interface flapping or you will see really crappy data rates, although there would be a better access point closer by, but it's just not working because both of them are in auto channel settings, auto frequency settings, and one did choose indoor and the other one outdoor. And I think something that probably all of you did already see is that you have full bars on your mobile device, but you can't connect to the access point. And it's the same problem. The access point is using high TX power, and the mobile phone simply can't find its way back. To give you figures for an iPhone 5, for example, it has a maximum TX power in 5 gigahertz of 12 dBm, and even a negative antenna gain of -0.8. So it will drop you with an EIRP of about 11 dBm. So very often it will be pointless to have a higher power set at your access point. It's not 100% true, since the access point has better receiver sensitivity, so it can actually use a smaller signal. And the way back is like your upstream. You might be happy with a smaller data rate there, since you need the big capacity in the downstream. So it's not a black and white decision, but still keep into mind that higher TX power doesn't necessarily mean a better Wi-Fi network. So let's leave the channel planning and spectrum usage and have a look at a security feature. Well, it's not really a security feature, but I accounted to them. That's the upgrade policy. From our customer base, we see it's not that often used, and I actually don't know why, so that's why I decided to introduce it here. Upgrade policy will enable you to do automatic upgrades, router OS upgrades from your CAPs manager to all connected CAP access points. There are three settings you can take for it. None will simply do nothing. Suggest will suggest the access point to upgrade, and if it can't upgrade, it will still provision it, and will require the access point to upgrade, and if it can't, it's not going to provision it and simply kick it out. The nice thing here is the CAP itself doesn't need an internet connection. So if we scroll back a few slides, we were talking about manager forwarding mode, and that in manager forwarding mode your device is not needing an IP address or any connection anywhere, but uses its automatically created UDP tunnel. And in here we see that for software upgrades it doesn't need an internet connection, so that can add up to security to keep your access points out of the network. If CAP and CAPs manager use the same architecture, things are like fire and forget. It's quite easy. All you have to do is set the upgrade policy and nothing else to take care of. What you see here is an example with CAP and CAPsManager using different architectures, like an hub light, which is SMIPS as a CAP, and RB750UP as a CAPsManager, which is MIPS BE. And the MIPS BE simply doesn't have the router as firmware for a MIPS MIPS SMIPS device. So that's what you see here. The CAP can't download the upgrade file. In that case, you have to take care for a couple of things. On one hand, you have to create a folder, as you see in figure 2. You can use FTP as router, as is not yet giving you features to create folders. And then you name that folder in the package path, and then simply drop the package you need here in the package path folder. And at figure 4, we're disconnecting or throwing the CAP out, forcing it to reconnect. And now it will find the router as package of the different architecture and can upgrade and be provisioned again. So pretty easy. And if you look at the recent history at the CIA leak, for example, leaking an exploit for router OS, this is a very easy way to upgrade your maybe hundreds of devices with a single upgrading or uploading of a package. So it might be worth to think about that. The drawback, of course, is if you provision a non-working package to a couple hundred of routers, you're in trouble too. So now the last topic of my presentation, that's Wi-Fi security or access security using CAPsManager. And first of all, I want to go through the list of possible encryption strategies or security possibilities. First of all, of course, we have WPA with pre-shared keys, most commonly used. Here it's important to understand that when you are using CAPsManager, you have a central place where you can change the WPA encryption key for all of your clients, which might be pretty handy. You can also go another step and use the access list to create conditional pre-shared keys. And we can even go ahead and create a pre-shared key per client MAC address, so we can create individual pre-shared keys being bound to the MAC address of a device. A second approach, which is actually, from my understanding, used not often enough, that's enterprise WPA or WPA EAP. There are two different versions or two different approaches on router OS. We can use EAP TLS, which is natively supported by router OS, or we can use pass-through, which means the client will pass its request through to a radio server. And of course, next to the encryption capabilities, there's the possibility to use hotspot. That is not to encrypt your Wi-Fi, but to authenticate the access to the network. And that's what I want to look at first. And I have to admit, personally, I really love this example because it's so simple and clean, and you can create really huge networks, and it's almost fail-safe. So let's spend some time here. When we are in manager forwarding mode, we have all our client connections being transported by automatically created UDP tunnels to the CAPsManager. And there you can choose which bridge they should pop up. Now the idea here is that on the very same bridge you're creating a hotspot. So you have the MikroTik hotspot feature on the same bridge where your client connections from the CAPs are popping up. So you really force the complete traffic of possibly hundreds of access points to go straight to a hotspot feature where they can be authenticated for network access. And all you have to do is a couple of easy steps. And number one, you see we are choosing the bridge in our data path configuration. In figure 2, you see we're not configuring local forwarding. On figure 3, there is a hotspot being created on the same bridge, on the same device. And on figure 4, you simply see that we do not include any WAN interfaces as parts of that bridge. So that's all there is to do to build the base of a real, potentially huge hotspot network. It's secure, it's efficient, it scales well, and the traffic handling is all done for you. So there's no breakout possibility to the local network. If you start building these huge hotspots, you will probably sooner or later see that there are a couple of features that the hotspot facility of MikroTik will not provide for you, like higher level captive portal features. And there is a very good product, actually it's made in Italy, that I want to introduce here. It's an extension for the MikroTik hotspot called HSNM. It offers very tight integration with MikroTik. Like it gives you installation scripts and update scripts made automatically for you. It will even be possible to use it as a backend for PPPoE, but that's a different story. And the company has a really experienced support team when it comes to MikroTik installations, as they're really focusing on that. And what it will give you on top of the hotspot, excellent captive portal features and a very good graphical design. Just to name a few features before we continue, you get a responsive login page, you have heaps of payment options. There are, let's say, more fancy stuff like GPS tracking. If you use your hotspots or access points and coaches, for example, they can track the way they are driving. There are ticket printers available. It'll give you social login, redundancy of the backend and load balancing, SMS authentication, which is actually a feature German customers are regularly requiring. And it has additional modules that I don't want to look into now, like an advertising feature, surveys or quizzes. Just to give you an idea, here's a screenshot of the backend. And the company is actually here as an exhibitor in the distributor part. So if you're interested, just drop by their table. Or of course, you can ask my colleagues too. So I think I got 3 more minutes and 9 seconds. So I'll try to walk you through 2 more topics. Just very short, so we don't lose too much time, is the Mac-based pre-shared key. That's possible to be set up with User Manager. So no external tools are needed here. The idea is you have a personal pre-shared key for each of your mobile devices by naming its MAC address. The keys will be stored in User Manager, and you will not need a full radios infrastructure, so that's fairly easy to set up. What happens in short word is CAPsManager will send the MAC address of the device to radios, ask for a personal pre-shared key for that MAC address, get the MAC address, the pre-shared key back, and finally compares if the one the client is using matches the one User Manager did give it back. So it's kind of Enterprise WPA Lite, maybe. And finally, it will grant or decline access. To set it up, you will first have to name a radio server on your CAPsManager. That is the typical configuration for radios. You name its IP address, a secret. You check which services it should be responsible for. And then the easiest setup, you simply run User Manager on the same device that you run CAPsManager on. Now the CAPsManager configuration is a little bit disordered maybe. There are a couple of areas where you have to take care of. First of all, the security profile, where you choose WPA2. Then second, you have to set an access list action. That is the action to ask radios. And last but not least, here at the AAA button, number 3, you have to set the MAC format, and you have to explain what to do with this MAC address. That is, we want to use it as a username with our radios authentication. At the User Manager end, there's not much to do. As usual, you have to allow the CAPsManager to send its radios inquiries to the radio server, so you configure it as a NAS, or here it's called as a router, by naming its IP address and the secret to use. And then you can start setting up your user accounts by naming the MAC address as a username and the pre-shared key in the pre-shared key field. And that's all there is to do to set up MAC address-based pre-shared keys for each of your devices. So the last topic would be Enterprise WPA and how to set it up. First of all, the security setting here is different because you will check WPA EAP. And when we use EAP we have two options, and we will use pass-through. Pass-through means the end user device, the supplicant on your iPhone, for example, will send its inquiry directly to the radio server, and the two of them will handle the authentication method. We won't stick here too long due to time, but what you will be using is PEAP, that's Protected Extensible Authentication Protocol. In our case, it means that you will typically send MS-CHAP requests through an encrypted TLS tunnel to your radio server. As we've seen before, we have to set up radios. It's the very same configuration as we have with the Mac-based encryption keys. And the sad thing here is that User Manager is not yet supporting it. According to my knowledge, in version 7, this will change. But for now, you will need an maybe easy to set up radio server. And of course, there's free radios and there are lots of other vendors. But I want to introduce a very easy to set up and free to use appliance, which is called Zero Shell. It's ready to run. You can simply download it, and it will just take you a couple of clicks to have it running. And once you have it running, there are just 3 things you have to do. You have to enable radio service on it. That's done here. Again, you have to add the CAPS manager as an allowed NAS, setting up client name, an IP of the CAPS manager, and a shared secret. And then you can go ahead and create your user accounts, your enterprise WPA2 user accounts. So what you do for that is you go to the user management, say add username, first and last name, the password, and finally make sure you check radios down here and to uncheck Kerberos, as that one would allow access to the user interface of Zero Shell, what you probably don't want. It's really done in minutes and might be a solution until User Manager supports that. And once you did that and try to connect to your SSID, you will be asked for username and password, so not only the encryption key, but username and password. You can give that. Afterwards, you will be asked, at least in the standard setup, to trust the self-signed certificate ZeroBox is coming with. And once you did that, you're connected to your SSID using Enterprise WPA. Wow. I'd say I'm just in time, 2 minutes 40 too much. Sorry for that. I hope it was interesting and you saw a few new approaches on what to do with this great tool, CAPS Manager, and wish you a great mom and enjoy your time here. Thank you.